In a particular region of the cosmos, an unseen power is tugging on our own galaxy and countless others, drawing them in at velocities reaching hundreds of kilometers per second. Yet it remains invisible to us. Known as the Great Attractor, this gravitational anomaly has been a profound puzzle for astronomers for decades, concealed from our direct view behind the dense curtain of the Milky Way. So, what exactly lies there, capable of influencing such enormous cosmic structures? This journey is dedicated to one of the most perplexing and unsettling phenomena in the known universe. We will explore the Great Attractor's crucial role in contemporary astronomy and the secrets it holds. Because understanding this immense concentration of mass, located hundreds of millions of light-years away, reveals how it shapes not only its immediate galactic neighborhood, but the very fabric of the cosmos. Naturally, the first question to address is how the Great Attractor was ever discovered. The story starts in the 1980s, when astronomers realized that the motion of our Milky Way galaxy was not random. It possessed a definite direction, guided by an external force, which immediately led scientists to wonder about its origin and to theorize that something unseen was pulling us toward it. As we investigate the potential answers, it becomes clear that the Great Attractor is just one component of a much grander design. Across the vast expanse of the universe, galaxies are not scattered haphazardly. Instead, they are organized into immense, interconnected structures. Understanding the Great Attractor's position and its influence helps us begin to grasp the sheer complexity of this cosmic organization. Gravity, a force you might take for granted, plays the central role in this entire cosmic drama. The same force that anchors your feet to the ground is responsible for sculpting and forming entire galaxies. The Great Attractor is fundamentally tied to this force, acting as a massive knot in the universal fabric, a dense concentration of gravity that warps and influences everything in its vicinity. This brings us to the question of its location. The Great Attractor is situated in a region of space that is hidden from our direct line of sight, in the direction of the constellation Centaurus, an area dense with clusters of galaxies. The primary reason it is so challenging to observe is the thick veil of interstellar gas and dust within our own galaxy that blocks our view, forcing astronomers to seek indirect clues like detectives at a crime scene. As you trace the history of research into the Great Attractor, you find a fascinating evolution of theories. From the initial hypotheses to the latest modern studies, every new finding has represented a progression toward a more complete picture of this phenomenon. Yet, each new theory also introduces more questions, making the Great Attractor a perfect illustration of how scientific knowledge is built on a foundation of curiosity and relentless exploration. Examining the Great Attractor also compels us to consider the role of dark matter, an invisible yet dominant ingredient of the universe. Dark matter acts as an unseen player in this cosmic theater, shaping the movement of galaxies without being directly observable itself. As research progresses, it's becoming evident that the Great Attractor and dark matter are deeply intertwined, each forming an essential part of the universe's grand narrative. We also cannot overlook the expansion of the universe in this context. As all of space expands, the Great Attractor influences how galaxies cluster and navigate within this stretching cosmic medium. This dynamic invites us to contemplate the future. Will these galaxies continue their journey toward this gravitational center, or will there be a point when their movement halts or reverses? Looking ahead, the study of the Great Attractor is filled with unresolved mysteries and questions that still demand answers. This very search is what motivates scientists to continue their exploration of the cosmos. Each discovery about this immense structure brings us a step closer to comprehending the fundamental nature of the universe and our own place within it. The Great Attractor is a genuine cosmic enigma. But what is it in simple terms? To grasp its nature, you must first picture the universe on its grandest scale. A vast web where galaxies are like nodes connected by threads. The Great Attractor is a point in this network, exerting such an immense gravitational pull that it draws countless surrounding galaxies toward it, much like a crowd being pulled toward an invisible magnet in a room. Situated in the direction of the Centaurus constellation, the Great Attractor lies approximately 200 million light-years from Earth. Its location is critically important because it helps define the very structure of our local universe. Imagine a major city hub where numerous highways converge. In a similar way, the Great Attractor acts as a focal point, directing nearby galaxies into a massive flow that resembles a cosmic river. So, how did astronomers become aware of something so immense yet invisible? It was during the 1980s that scientists first noted a peculiar pattern. Our neighboring galaxies, along with those much farther away, were all moving in a strangely unified direction, providing the first major clue to the existence of this hidden cosmic titan. The concept of the Great Attractor, a potent and enigmatic force within the cosmic expanse, wasn't always part of our understanding. For a long time, its very existence was a puzzle that confounded astronomers. So, how did we come to discover this phenomenon, which appears to shape the fundamental structure of our universe? The narrative of the Great Attractor starts in the 1970s, a time when researchers first detected peculiar anomalies in the way galaxies were scattered across space. At that time, observations revealed that certain galaxies were traveling in directions that the gravitational pull of their neighbors alone couldn't account for. It suggested the presence of an unseen power, like a colossal cosmic magnet drawing these galaxies toward a single location. Rather than expanding uniformly in every direction, much like confetti tossed into the wind, they appeared to be converging on a distinct point, a finding that sparked a wave of compelling new questions. What could possibly be the nature of this enigmatic object, capable of pulling in such a vast number of galaxies? As researchers delved deeper, it became clear that they couldn't observe it with conventional instruments. Consequently, they had to rely on deductions drawn from the motion of galaxies and their gravitational interplay. You can think of it as standing in a pitch-black room and feeling a push from an unseen source. This analogy captures the very essence of the Great Attractor. Our certainty of its existence comes from the influence it exerts on the trajectories of other celestial objects. In this cosmic drama, gravity plays the leading role. The very same force that anchors your feet firmly to the Earth operates on an immense interstellar scale. You can envision gravity as the fundamental adhesive that binds entire galaxies into coherent structures. The gravitational pull of the Great Attractor, however, is more akin to an industrial-strength superglue, irresistibly drawing neighboring galaxies into its grasp. Could you picture existing in a region where this binding force is so overwhelming that escape is impossible, regardless of your efforts? This is precisely the kind of gravitational environment that defines the space around the Great Attractor. It's truly remarkable to consider that even our home galaxy, the Milky Way, is not fixed in space. In reality, it is engaged in a continuous gravitational tango, slowly moving toward the Great Attractor. This implies that far into the future, our galaxy could be situated much nearer to this enigmatic focal point. But what are the consequences for our galaxy? The answer is found in the way this immense pull shapes the motion and arrangement of our stars and planetary systems, almost as if the Great Attractor is a celestial conductor directing the symphony of hundreds of thousands of stellar bodies. The reach of the Great Attractor's influence extends even further. Scientists began to unravel this mystery when they focused their studies on a patch of sky toward the constellation Centaurus. It is in this direction that the Norma cluster is located, a massive collection of galaxies now understood to be a key component of the Great Attractor itself. You could picture the Great Attractor as an enormous magnet, and the Norma cluster as a collection of metallic objects irresistibly pulled toward it. This dense cluster is home to countless galaxies, each following its own trajectory, yet all moving inexorably toward this gravitational center. This then brings us to the cosmic microwave background, which is also known as relic radiation, the faint thermal afterglow that permeates the entire universe. This background radiation serves as a kind of echo from the Big Bang, providing evidence that the cosmos is still expanding. Through careful analysis of this ancient light, scientists have uncovered hints about the universe's large-scale structure and its relationship with the Great Attractor. It's almost like possessing an ancient treasure map that guides our understanding of where this enigmatic object is located. So, how can we possibly study the Great Attractor when it remains invisible to us? Astronomers employ a wide array of methods, ranging from high-powered telescopes to sophisticated computer models to analyze its cosmic influence. These investigative techniques are similar to a detective examining the evidence left behind by moving galaxies, where every subtle shift in motion reveals another part of the story about the Great Attractor's universal impact. A particularly fascinating element of the Great Attractor is its link to dark matter. While this enigmatic substance is completely invisible, we are certain of its existence due to its gravitational effects on galactic behavior. As a primary center of gravity, the Great Attractor itself is likely shaped by the vast halo of dark matter that envelops it. It's truly mind-boggling to contemplate that something unseen can exert such a profound influence on the very architecture of the cosmos. With each new finding about the Great Attractor, our exploration of the cosmos compels us to reflect on its largest structures. This serves as a powerful reminder that the universe is far more than a random assortment of solitary galaxies. It is a deeply interconnected system. The Great Attractor represents a crucial piece of this cosmic puzzle, affecting not just its local environment, but also our fundamental comprehension of universal expansion and its origin story. When you examine the Great Attractor's relationship with the expansion of the universe, you realize there are much larger forces at work. This gravitational anomaly impacts more than just what is observable. It holds profound implications for the ultimate destiny of the cosmos. Will its immense pull on galaxies persist indefinitely, or will its power eventually wane? The solution to this puzzle could radically alter our theories about the final fate of the universe. Ultimately, any contemplation of the Great Attractor brings us face to face with a host of unanswered questions. Scientists remain perplexed by inquiries into its fundamental nature, its true cosmic influence, and even the precise details of its existence. Every fresh discovery compels a re-evaluation of our grasp on gravity, dark matter, and the very fabric of spacetime. For this reason, as our exploration continues and our knowledge of the Great Attractor grows, we are doing more than just analyzing a point in space. We are examining our own position within this immense universe, where every answer we find seems to generate even more questions. As astronomers deepened their investigations, they began to accumulate evidence that indicated a colossal concentration of matter was influencing the motion of galaxies in its proximity. While the concept of such a massive object was initially accepted, subsequent observations made it apparent that the visible matter was not nearly enough to generate the gravitational forces at play. This is the precise point where dark matter emerges as a concealed yet essential element in the saga of the Great Attractor. To help you visualize this, imagine the universe as a vast ocean and galaxies as vessels sailing upon it. The Great Attractor would be akin to a gigantic, undiscovered island, whose immense pull causes nearby ships to veer off their intended courses. This island, however, is impossible to see directly. Its existence can only be concluded from the effects it has on its environment, which is exactly how scientists inferred the presence of the Great Attractor. With the development of new technologies and the construction of more powerful telescopes, astronomers began to study this specific region of space in greater detail. They found not merely a cluster of galaxies, but an area abundant with complex structures, including filaments of dark matter. These filaments function like cosmic pathways, linking different galaxies and channeling their movement in the direction of the Great Attractor. The history of the Great Attractor is a testament not only to discovery, but also to scientific partnership. Researchers from all over the globe have invented to investigate this phenomenon, with each new piece of data serving as another brick in a continuously growing structure, bringing the image of the Great Attractor into sharper focus. Despite these accomplishments, however, many questions still linger. What gives the Great Attractor such immense power, and what other secrets are concealed within its influential depths? Science has always been driven to solve such enigmas, and it is often the questions without immediate answers that are the most captivating. These knowledge gaps are where human curiosity thrives, compelling us to push the boundaries of exploration. The narrative of the Great Attractor also offers you a lesson on the fundamental nature of science itself. Every new discovery inevitably raises new questions, and each answer unlocks a doorway to further mysteries. In this way, the Great Attractor transcends being a mere object of study. It stands as a symbol of humanity's unending quest for knowledge. Reflecting on its discovery serves as a powerful reminder of how little we genuinely understand about the cosmos. It highlights the sheer vastness and complexity of the universe we inhabit, leaving you to wonder how many more secrets await future generations in the boundless expanse of space. The fascinating tale of the Great Attractor is just one chapter in a much grander story, where each advance in our cosmic understanding inches us closer to the truth, and every question we pose sparks new voyages of discovery. What other enigmas has the universe held in store for us? The solution to that puzzle might be nearer than you imagine. What grants an object in the cosmos the power to draw everything around it? The answer to this question brings us to one of the most fundamental forces known to science: gravity. Gravity is the cosmic adhesive that binds everything together, from the smallest pebbles on Earth to the most massive galaxies across the immense universe. But how does it operate, and why is it simultaneously so powerful and so enigmatic? To grasp the concept of gravity, let's use a simple analogy involving a trampoline. When a person sits in the middle, the fabric stretches downward, forming a depression. If you were to roll a marble near this dip, it would naturally travel toward the center, following the curve. In this metaphor, the trampoline is space-time, and the person represents a massive body like a planet or a star. Gravity is the resulting force that makes other objects, like the marble, move along that curve toward the mass. Now, let's expand this concept to a much larger scale. In the context of the Great Attractor, we are not discussing a single planet or star, but an entire supercluster of galaxies that wields an extraordinary gravitational pull. This force is so potent that it affects a vast collection of galaxies, including our own Milky Way. But how can an object so distant exert influence on our corner of the universe? The answer is found in the way gravity functions over immense distances. Although the separation might seem like an insurmountable barrier, gravity has the capacity to extend across vast cosmic voids. Consequently, even though the Great Attractor is located hundreds of millions of light-years from us, its gravitational force remains strong enough to shape the movement of galaxies in its vicinity. You can think of it like a colossal magnet that, despite its distance, can still attract metallic objects within its field. The consequences of the Great Attractor's gravity are clearly visible in the motion of surrounding galaxies. When you observe our galactic neighborhood, you notice that galaxies are not moving about randomly. Instead, they seem to be engaged in a coordinated dance, their trajectories guided by the immense pull of the Great Attractor. To understand what this implies for the universe's overall structure, picture a group of friends walking through a park. If one person begins to run in a specific direction, the others will likely follow, creating a discernible pattern. In a similar fashion, galaxies under the influence of the Great Attractor tend to cluster and travel in particular directions, compelled by the powerful gravity that radiates from this supercluster. This phenomenon illustrates how gravity is capable of organizing matter into large-scale structures across the cosmos, which then raises the question of the link between gravity and time. Gravity's influence extends beyond just the motion of objects. It can also warp time itself. Within powerful gravitational fields, like the one produced by the Great Attractor, time actually unfolds more slowly than in areas with weaker gravity. This means that on a cosmic scale, the Great Attractor not only dictates the movement of galaxies, but also shapes our very perception of time, which is a truly staggering thought. Our own galaxy, the Milky Way, is being pulled toward the Great Attractor at an incredibly high velocity. While this is a motion you don't notice in your daily life, it serves as a powerful reminder that we exist within a dynamic and constantly evolving universe. The night sky may seem serene, but across the vastness of space, a cosmic ballet is in full swing, with gravity conducting its rhythm. It's also fascinating to contemplate how the Great Attractor's immense gravity might be a key ingredient in the birth of new stars and galaxies. Areas with more intense gravitational pull can accumulate greater amounts of cosmic material, which in turn can ignite the formation of new stars and solar systems. In this way, the Great Attractor not only steers the paths of existing galaxies, but also participates in creating new cosmic structures. Of course, not everything about this phenomenon is fully understood. Even though gravity is a familiar force, many mysteries remain about its behavior on such immense scales. What other elements could be influencing the trajectories of galaxies? Are there other, yet undiscovered forces at play? These questions contribute to the deep sense of intrigue surrounding the Great Attractor and its cosmic dominion. Gravity is undeniably a complex subject, yet its elegance is revealed in how it weaves together every component of the cosmos. It reminds you that while we may be just a tiny piece of this immense universe, every star, planet, and galaxy is connected within a gravitational web that impacts us in ways we are still struggling to comprehend. So, the next time you gaze up at the night sky, recall that every glimmer of light is in constant motion, propelled by the unseen yet formidable power of gravity. To appreciate the relationship between our home galaxy and the Great Attractor, you first have to picture the Milky Way as a small island within a vast galactic archipelago. Each of these islands has its own unique history, yet all are bound together by the invisible currents of gravity flowing between them. The Milky Way resides in a pocket of space where the Great Attractor's gravity functions like an incredibly powerful magnet, its influence felt across our entire galactic neighborhood, despite being hundreds of millions of light-years away. Have you ever considered the profound impact this has on our cosmic journey? You see, the Milky Way is not simply drifting aimlessly through the void. It belongs to a cluster known as the local group, which also contains the well-known Andromeda galaxy and numerous smaller ones. But this local cluster is merely a small component of a much grander structure, all moving together toward the Great Attractor as if drawn to a distant cosmic destination. This gravitational pull is so immense that it directly influences both the speed and the direction of all nearby galaxies. If you could witness this galactic dance, you would observe a distinct pattern in their movements, a cosmic flow that points directly to the presence of the Great Attractor. In this vast expanse, the Milky Way is traveling at a breathtaking speed of approximately 600 kilometers per second, its trajectory guided not by chance, but by the gravitational beacon of this mysterious cosmic anomaly. This movement is not an isolated event, but rather a central part of a larger cosmic choreography that involves hundreds of thousands of galaxies. The Great Attractor's influence isn't confined to the Milky Way. Every galaxy in its vicinity is caught in its gravitational sway. Imagine a whirlpool in a vast pond, where every leaf that falls in is swept along by the current. In a similar fashion, nearby galaxies are drawn toward this enormous concentration of mass. So, what are the ultimate consequences of this relationship between the Milky Way and the Great Attractor? The way our galaxy moves has significant implications for our understanding of the universe as a whole, as this gravitational attraction helps sculpt the superclusters of galaxies and gives form to the large-scale structure of the cosmos. However, the journey is anything but simple. As it moves, the Milky Way engages in complex interactions, sometimes merging with other galaxies and at other times deflecting them, highlighting the beautifully chaotic nature of the universe. This profound connection between our galaxy and the Great Attractor also invites you to ponder your own place in the universe. Although we are a very small part of this vast network, every star in our galaxy is part of an incredible story. Our home, on its perpetual journey toward the Great Attractor, is a constant reminder that we are always in motion. This realization naturally leads us to ask, what other wonders lie waiting to be discovered out there? You are likely familiar with gravity as the force that keeps your feet on the ground. But have you ever considered its profound impact on the entire universe? Across the immense expanse of space, a mysterious object known as the Great Attractor functions like a colossal cosmic magnet, powerfully shaping the trajectories of countless galaxies. To truly grasp what this means, picture yourself in a park filled with children at play. While some run in circles and others chase each other, a group suddenly decides they will all race toward a single, specific point. This is precisely how the Great Attractor influences galaxies, dictating their collective direction of movement. To better understand this cosmic phenomenon, it's essential to appreciate how gravity operates on truly massive scales, far beyond just keeping us anchored to Earth. This fundamental force also governs the interactions between immense celestial bodies, including entire galaxies. In this context, the Great Attractor exerts a powerful gravitational pull, drawing galaxies toward its center as if it were the core of a vast system of interconnected magnets. The evidence for this comes from direct observation. By using powerful telescopes, astronomers have noted that a great number of galaxies are indeed streaming toward this specific region of space, much like watching water swirl as it flows into a drain. But you might wonder, what about the galaxies that appear much farther away? Are they exempt from this powerful force? The truth is that every galaxy is subject to gravity's influence, although the effect diminishes with distance. Consider a more relatable scenario. Imagine you are a passenger on a moving train. Looking out the window, you see trees and buildings seeming to rush past, yet observing the interior of the train car confirms that you are also in motion. In much the same way, galaxies nearer to the Great Attractor are pulled directly toward it, while more distant ones may appear to travel in different directions due to their own relative motion. Understanding these cosmic movements is crucial because the gravitational pull of the Great Attractor is a key factor in shaping the very structure of our universe. By influencing how galaxies congregate and travel, it helps to construct the grand architecture of the cosmos. You could think of the Great Attractor as the conductor of a celestial orchestra, guiding each galaxy on its unique journey through space. Without this gravitational guidance, the universe might be a far more chaotic place, filled with disorganized, wandering galaxies instead of the magnificent, ordered structures we observe today. This might seem incredibly distant, but how does it connect to our lives here on Earth? By gaining a deeper understanding of how this gravitational force works on a galactic scale, we also come to better comprehend our own existence within the cosmos. The very same force that orchestrates the dance of galaxies is responsible for the Earth's orbit around the Sun and the Moon's orbit around us, revealing that everything is interconnected in remarkable ways. As we continue to study the Great Attractor, we are faced with compelling questions about its potential influence on the destiny of our own Milky Way galaxy. And the answer to that question is a definitive yes. In the far distant future, our own Milky Way is expected to be pulled inexorably toward the Great Attractor, where it will likely merge with other clusters of galaxies. Such collisions are spectacular cosmic events that can trigger the birth of new stars and even entire planetary systems. This kind of dynamic process serves as a powerful reminder that the universe is a place of constant evolution and change, where the Great Attractor's gravity not only steers the motion of galaxies, but also provides a glimpse into the past and future of our cosmos. In a way, we are all spectators of a magnificent cosmic dance, where every galaxy performs its part, guided by invisible forces. When you reflect on gravity and its role in the Great Attractor, it's incredible to realize how these unseen tethers connect us all. Every star, every planet, and every galaxy is in constant motion, propelled by this fundamental force. So, the next time you gaze up at the night sky, remember that you are not just seeing distant points of light, but the breathtaking outcome of gravitational forces at work on a grand scale. Ongoing research into the Great Attractor continues to unveil more about the fundamental nature of the universe. As astronomers pioneer new technologies and observational techniques, we anticipate solving even more of the puzzles surrounding this enigmatic cosmic object. What other secrets does the Great Attractor conceal? While only time will reveal the answers, one thing is certain. Each new discovery brings us closer to understanding our true place within the vast tapestry of the cosmos. So, the next time you think about gravity, remember that it's more than just the force holding you to the ground. It is the fundamental power that binds galaxies, directs the flow of the universe, and ultimately connects every one of us. The Great Attractor reminds us that even though we may feel small in the face of infinite space, we each have a role in this grand cosmic symphony, where exploration will undoubtedly raise more questions than answers. Within this mystery lies the Norma cluster, a fascinating region of our universe that is central to the enigma of the Great Attractor. But what makes it so special? To understand that, we must first explore the concept of a galaxy cluster. Picture the cosmos as an immense sea dotted with galaxies, each one an island of stars. The Norma cluster represents one of these galactic archipelagos, a massive collection of hundreds of galaxies held together by their mutual gravity. Situated approximately 400 million light-years from Earth, it might sound incredibly distant, but in cosmic terms, it's actually one of the nearest major clusters to our own local group. This relative closeness provides you with a remarkable opportunity to observe the behavior of galaxies when subjected to immense gravitational fields. This brings us to its connection with the Great Attractor, a specific region in space exerting such a powerful gravitational tug that it pulls numerous galaxies, our own included, toward it. The Norma cluster resides right at the heart of this phenomenon, playing a central role in this grand celestial narrative. You could think of the Great Attractor as conducting a symphony, with the galaxies of the Norma cluster moving in time with its gravitational rhythm. Among its most distinguished members is Centaurus A, a galaxy recognized for its luminous and dynamic center. Its peculiar form and high rate of star creation make it an object of intense fascination and study for scientists trying to understand this cosmic performance. The mysteries locked within Centaurus A might hold the key to better understanding the Great Attractor itself. The interplay among the galaxies in this cluster is more than just a gravitational ballet. It is a powerful agent of change. Since galaxies are constantly evolving, their close encounters can lead to dramatic mergers and collisions, which in turn ignite furious episodes of new star birth. When a galaxy succumbs to the gravitational influence of its neighbors, the result is often the formation of entirely new star systems. Throughout this celestial display, galaxies mutually affect one another's form and composition. For instance, a galaxy might find its spiral arms elongated, or it could be stripped of the gas and dust necessary for stellar creation. This prompts you to wonder about the lasting effects of these interactions and their significance for studying galaxy clusters across the universe. Looking at the Norma cluster is also a form of time travel into the deep past. The light reaching your eyes from these distant galaxies began its journey hundreds of millions of years ago. Consequently, when you observe the cluster today, you are actually seeing it as it existed long before our time, offering clues about the condition of its galaxies in a much younger universe. To probe the Norma cluster and its relationship with the Great Attractor, astronomers employ a diverse array of instruments. Each tool, from optical to radio telescopes, provides a distinct viewpoint. Certain telescopes, for example, can perceive long wavelengths of light that are invisible to us, revealing the energetic processes occurring deep within galactic cores and helping you piece together the puzzle of these massive structures. This cosmic dance isn't merely a regional event. Galaxy clusters are fundamental building blocks of the universe's architecture. The manner in which they group together and are drawn toward the Great Attractor offers insights into the cosmos's large-scale framework. This ultimately guides you toward one of the most profound questions in science. What is the overall distribution of matter across the universe? And what are the implications for our comprehension of reality? Any exploration of the Norma cluster inevitably leads you to the enigmatic idea of dark matter. While it remains invisible to our instruments, its gravitational effects are essential for shaping galaxies and orchestrating their movements. Understanding the link between dark matter, the Norma cluster, and the Great Attractor is a critical step toward a more complete model of the universe's fundamental nature. The Norma cluster presents you with more than just a compelling scientific subject. It poses profound questions about the distant future. With its galaxies perpetually interacting and merging, you are left to wonder how this massive structure will transform over billions of years. Such inquiries naturally lead to broader reflections on the ultimate destiny of the cosmos and our place within it. It is truly inspiring to realize that even at such a great distance, the Norma cluster is fundamentally connected to us. By investigating this cluster, you gain knowledge not just about gravity and matter, but also about your own context in this immense universe. Our endless curiosity compels us to probe deeper into these cosmic mysteries, where every answer only uncovers more fascinating questions. reminding you that each new discovery brings us closer to comprehending the cosmos. Now, you might wonder about the cosmic microwave background, also known as relic radiation, and its relevance to the Great Attractor. This concept is key to understanding your position in the cosmos. It's essentially the faint afterglow of the Big Bang, the primordial event that created everything. This faint light permeates all of space, acting like a universal fossil that provides hints about the conditions of the universe in its infancy, billions of years in the past. So, what is the connection to the Great Attractor? The relationship is found in the way that extremely massive objects can alter the path of light. Consider turning on a flashlight in a pitch-black room. Its beam travels straight ahead. However, if a substantial object obstructs the path, the light will curve subtly as it passes by. And the Great Attractor has a similar, though far more profound, effect on the light of the cosmic microwave background. A similar effect occurs when the cosmic microwave background radiation travels near immense masses like the Great Attractor. The powerful gravity of this colossal structure can actually bend the light, which in turn skews how you perceive the surrounding cosmos, offering a distorted but informative view of the universe's grand architecture. The methods used to analyze this ancient radiation are key to unlocking cosmic secrets. Using telescopes and satellites, astronomers meticulously chart the temperature of the cosmic microwave background across the entire sky. The significance of this lies in what the temperature fluctuations reveal. They provide a detailed map of how matter is distributed throughout the universe, which includes the powerful gravitational signature of the Great Attractor. So how is this data transformed into actual understanding? By studying the cosmic microwave background, scientists can construct a structural blueprint of the cosmos, pinpointing areas of high and low matter density. You can think of it like a geologist examining a topographical map to grasp the contours of a mountain range. On this cosmic map, the Great Attractor manifests as a distinct hotspot, a clear signal of its existence and its staggering gravitational force. Therefore, the cosmic microwave background serves a dual purpose, offering a window into both the universe's history and its current state. It enables you to witness how the Great Attractor actively shapes the arrangement of galaxies and clusters, pulling them into a vast, interconnected structure, often described as the cosmic web. Yet, the more scientists investigate this relic radiation, the more profound questions arise. For instance, what causes the subtle differences in its intensity across various regions of the sky? Inquiries like this compel researchers to delve into the enigmatic nature of dark matter and how it might be linked to phenomena like the Great Attractor. This invisible substance, dark matter, constitutes a massive fraction of the universe's total mass, and its interplay with the cosmic microwave background is a subject of intense scientific interest. You can picture dark matter as a colossal jigsaw puzzle. With each new piece discovered, your comprehension of the universe's mechanics sharpens, and the cosmic microwave background is one of the most crucial of these pieces. Indeed, analysis of the cosmic microwave background has been a cornerstone in the construction of modern cosmological models. It has provided the evidence needed to validate concepts like the expansion of the universe and the formation of its largest structures. Consequently, by examining the Great Attractor and its vicinity, you are gathering vital data that sheds light on the very evolution of the cosmos. It's truly remarkable that a phenomenon as ancient and remote as the cosmic microwave background can so directly influence our comprehension of the universe today. This relic light allows you to trace the development of the Great Attractor's gravitational influence across billions of years. observing how it has steered the paths of countless galaxies. Let's reflect on what this implies for your perspective on the universe. The cosmic microwave background is more than a mere glimpse into the distant past. It serves as a profound reminder that everything in the cosmos is fundamentally connected. Every star, galaxy, and cluster, including the Great Attractor, is engaged in an intricate cosmic ballet that is constantly unfolding. Through the study of these phenomena, you aren't just searching for answers, you are also coming to terms with our own position within this immense and magnificent creation. So, the next time you gaze up at the night sky, imagine the cosmic microwave background as the universe's faint whisper, a reminder that each point of light is a character in a much grander narrative, one that features the Great Attractor and its profound impact on the fabric of space-time itself. So, what techniques are available for observing the universe that surrounds us? The field of astronomy has advanced dramatically, with observation being one of our most potent instruments. The challenge, then, is how you can possibly study something as immense and remote as the Great Attractor. The solution is found in a range of clever methods that let us see far beyond the limits of human vision. Let's begin with telescopes, which act as enormous eyes, gathering light from faraway celestial bodies. Yet their function extends beyond mere sight, into a form of listening, as they can detect radio waves, X-rays, and infrared radiation in addition to visible light. Each part of this electromagnetic spectrum narrates a unique cosmic story. For instance, X-rays can expose intensely hot zones like those surrounding black holes, whereas radio waves map out cold gas clouds and other vast structures. And what role do simulations play in all of this? Contemporary technology enables the creation of detailed, three-dimensional cosmic models. You can envision it as a sophisticated video game where you can manipulate your viewpoint to watch how galaxies respond to the gravitational pull of the Great Attractor. Such simulations are indispensable as they provide a virtual laboratory for testing and forecasting galactic movements and clustering, thereby clarifying the universe's large-scale architecture. But how can you be certain that your observations are truly focused on the Great Attractor? This is where a technique called triangulation becomes essential, which is conceptually similar to determining a tree's height from the length of its shadow. By observing an object from two distinct vantage points and measuring its apparent shift against the background, astronomers can precisely calculate its distance and position, which is how the locations of galaxies around the Great Attractor have been mapped. As researchers compile this wealth of data, they encounter the next hurdle, its interpretation. According to Einstein's theory of relativity, gravity isn't merely a force. It fundamentally warps the fabric of space and time. Therefore, when you observe the motion of galaxies, you're not just watching their trajectory, but are also witnessing how space itself is curved by the presence of colossal objects like the Great Attractor. Have you ever come across the concept of gravitational lensing? A remarkable phenomenon unfolds as light from a very distant object warps when it travels near a massive body. You can picture the Great Attractor as an enormous cosmic lens that distorts the appearance of galaxies situated behind it. This gravitational lensing effect not only allows us to peer at what lies on the other side of this mass, but also enables us to calculate the amount of matter in that region, including the deeply intriguing dark matter. To observe the Great Attractor, satellites are just as vital as telescopes and simulations. By being positioned in space, high above the distortions of Earth's atmosphere, they can gather data free from interference. This positioning provides astronomers with significantly clearer and more precise images of faraway celestial objects. Indeed, space-based observatories such as the Hubble Space Telescope and the James Webb Space Telescope have completely transformed our capacity to view the universe. We also cannot overlook the importance of global cooperation in this endeavor. Astronomers across the planet collaborate by sharing their data and pooling their resources. It's as if you're assembling a vast cosmic jigsaw, where every scientist contributes a crucial piece. Only by bringing all these fragments together can we hope to achieve a more thorough understanding of the Great Attractor and its impact on the cosmos. Astrophysics also relies on a method known as spectroscopy, which allows us to analyze the light from galaxies. By separating this light into its constituent colors, we can uncover vital information about a galaxy's chemical makeup, temperature, and motion. This technique helps us better comprehend how galaxies are affected by the Great Attractor's gravity and how they move within its vicinity. But what occurs when the collected information doesn't quite add up? At times, astronomers face a genuine puzzle when their observations defy expectations. Even with a solid dataset, these are the moments that demand creativity and sharp critical thinking to formulate new hypotheses that can account for the anomalies. It's possible the Great Attractor isn't merely a huge cluster of visible matter. Perhaps it is enshrouded by structures we have yet to discover. As our observational methods and research capabilities improve, each new discovery seems to generate a fresh set of questions. Science itself is a relentless cycle of learning and exploration. Consequently, every answer we uncover about the Great Attractor prompts new inquiries into the nature of the universe, making us wonder what other mysteries are out there waiting for us. Human curiosity appears to have no limits, and the Great Attractor represents just one component of an immense and intricate puzzle. Looking ahead, new generations of telescopes and innovative technologies hold the promise of revolutionizing our comprehension of this cosmic anomaly even further. The quest for knowledge is ceaseless, and every technological leap brings us another step closer to solving the great mysteries of space. Dark matter is a concept that truly highlights this mystery. Though it remains unseen, we can detect its influence across the entire universe. But what exactly is this substance, and what is its relationship to the Great Attractor? To begin solving this puzzle, you must first grasp that dark matter is a type of matter that doesn't emit or reflect any light, rendering it totally invisible to our instruments. Despite its invisibility, we can infer its existence from the gravitational pull it exerts on visible matter, like stars and galaxies. You could imagine a sprawling, unlit city where you can only make out the pinpricks of light from buildings, yet you can feel that some larger, unseen structure is holding it all together. That binding force is analogous to dark matter. The Great Attractor, with its tremendous gravitational pull, functions like a cosmic anchor, drawing countless galaxies toward it. But this immense attraction would be impossible without dark matter, which is estimated to constitute about 85% of the total mass in the universe. To visualize this, you might think of dark matter as the fundamental framework of a massive structure. Without it, the entire edifice would simply fall apart. Our theories about dark matter have certainly changed over the years. Early on, it was hypothesized that it might be composed of particles already known to us, but the current scientific consensus suggests it is a completely different kind of matter that we have not yet directly observed. This idea implies that the universe is substantially more enigmatic than we can even begin to comprehend. The reach of dark matter's influence goes far beyond the Great Attractor dictating the very distribution of galaxies throughout the universe and governing their movements relative to each other. You could picture a cluster of berries, where the berries represent galaxies and dark matter is the invisible network of stems supporting them. Lacking this essential structure, the berries would disperse in every direction. This reality prompts a fascinating question. If dark matter is so fundamental, will we ever manage to detect it directly? Scientists are working tirelessly on experiments designed to identify dark matter particles. As of now, we have only witnessed its gravitational consequences, not the substance itself. It's akin to hearing a beautiful piece of music, but being unable to see the orchestra playing it. The melody is undeniable, but its source remains elusive. In this field, computer simulations have emerged as an incredibly useful tool. Astronomers construct models to forecast how the universe would evolve under the assumption that dark matter exists, and the outcomes are breathtaking. These simulations demonstrate that dark matter likely served as the primary catalyst for the formation of large-scale cosmic structures, including the Great Attractor and the superclusters surrounding it. When we contemplate dark matter, it is crucial to consider its part in the grand story of the universe's evolution. Galaxies, including the vast collections that constitute the Great Attractor, could never have developed into their present forms without the persistent influence of this invisible substance. It seems this mysterious material has been a central architect throughout the entire history of the cosmos. The universe is an immense and enigmatic expanse, far beyond our current comprehension, filled with breathtaking structures woven together in extraordinary ways. Among these massive formations is the Great Attractor. To truly grasp what this is, you must first envision the cosmos as a colossal web of filaments, with each thread representing an entire galaxy. Within this intricate network, the Great Attractor functions like an immense cosmic magnet, relentlessly pulling innumerable galaxies toward its core. Have you ever considered that the Great Attractor isn't a singular object, but rather the physical embodiment of gravitational forces influencing a staggering number of galaxies? You can conceptualize it as the epicenter of a colossal gravitational tempest. The origins of this cosmic storm trace back to the nascent stages of the universe, a time when gravity began pulling matter and energy into dense clusters, eventually giving rise to the galaxy clusters and superclusters we observe today. This cosmic web places the Great Attractor in a region of space that is exceptionally difficult to observe. It remains concealed behind the dense star fields and dust of our own Milky Way galaxy, rendering it a captivating puzzle. How could such a monumentally massive and powerful structure be so effectively hidden from view? The solution to this riddle lies in the vast cosmic distances and the thick veil of stars that obstructs our line of sight, compelling astronomers to devise ingenious indirect methods to study its effects. Galaxies are not merely solitary islands adrift in the cosmic void. They are intricately connected by filaments of dark matter that serve as bridges across this immense network. As a point of exceptionally high mass density, the Great Attractor powerfully sways the motion of these galaxies, drawing some toward it while propelling others away. This dynamic generates a kind of cosmic butterfly effect, where a seemingly minor adjustment in our own galactic vicinity could have significant repercussions in far-flung regions of space. Have you ever asked yourself how the Great Attractor's influence extends to the rest of the cosmos? If you picture the universe as a gigantic ocean, then the Great Attractor acts like a massive boulder disrupting the flow. As galaxies navigate these cosmic currents, their trajectories are bent and altered by the Great Attractor's immense gravity, which functions like a navigational beacon. This helps us contemplate the formation of even larger structures, such as vast galaxy clusters and immense walls of dark matter. The manner in which the Great Attractor impacts galaxies is a testament to the universe's profound complexity. For instance, galaxies in its immediate vicinity are pulled toward its center at incredible velocities. This movement isn't an isolated event, but part of a cosmic dance that underscores the fundamental interconnectedness of everything in the universe. By deciphering these dynamics, you can uncover clues about how the structures we see today originally took shape, even as the gravitational interactions around the Great Attractor present puzzles we are still actively trying to solve. When two galaxies clash within this region, what is the outcome? On some occasions, they merge to form entirely new galaxies, while at other times they merely glance off one another and continue on altered paths, prompting us to question the ultimate fate of these celestial travelers. Computer simulations have become indispensable tools, enabling us to visualize and comprehend these intricate interactions. Through these models, scientists can map the behavior of galaxies and see how they react to the Great Attractor's pull, which is truly remarkable given that we cannot observe the structure directly. Another fascinating dimension to this story is the Great Attractor's intimate relationship with dark matter. This mysterious substance, which emits no light or energy, constitutes the majority of the universe's mass and is instrumental in sculpting cosmic structures. In this context, you can think of the Great Attractor as a cosmic crossroads where visible matter and dark matter engage in extraordinary interactions. But what further insights might we gain from studying this relationship? Without dark matter, the majority of galaxies would lack sufficient mass to attract and hold on to their stars. If you imagine the universe as a vast ocean, dark matter is the water itself, providing the medium that supports everything within it. Lacking this fundamental substance, there would be no cosmic waves or currents, and the celestial landscape would be entirely alien to us. This makes dark matter essential, not only for understanding the Great Attractor, but also for comprehending the development of everything we know. The influence of dark matter extends beyond what we can directly observe. It also fundamentally alters how scientists perceive gravity across the cosmos. The very existence of this invisible matter has necessitated a revision of classical gravitational theories, compelling astrophysicists to investigate new concepts about the true mechanics of the universe. It's incredible to think that something so intangible could challenge our most fundamental grasp of physics. As our exploration of the Great Attractor and its connection to dark matter deepens, fresh questions continually emerge. Will we ever manage to uncover the true nature of dark matter? What profound implications might such a discovery have for our model of the universe? It seems that every answer we manage to secure only serves to unlock a door to even greater mysteries, which makes the pursuit all the more compelling. The study of dark matter also encourages us to reflect upon our own place in the cosmos, revealing that we are part of a much larger and more enigmatic network. Ultimately, the connection between the Great Attractor and dark matter represents a journey fueled by human curiosity and cosmic exploration. This quest to understand the unknown and push the boundaries of knowledge remains a mystery, but it is a mystery that compels us to keep searching and to constantly question what we believe to be true, defining the very essence of our species. While examining the Great Attractor's effect on galaxies, a larger question emerges about its impact on the expansion of the universe itself. This cosmic expansion is an incredible subject, and it's possible the Great Attractor alters its rate. This leads you to wonder, as space continues to stretch, is this massive anomaly guiding us toward some unforeseen cosmic destiny? When you contemplate the sheer scale of the cosmos and the intricacy of the Great Attractor, you're confronted with a limitless array of unresolved mysteries. Could this gravitational anomaly be linked to other cosmic events we haven't yet identified, possibly holding a vital clue for modern cosmology? The deeper you investigate, the clearer it becomes that this pursuit reveals as much about our own position in the universe as it does about the attractor itself. The enigmatic nature and gravitational power of the Great Attractor serve as a constant invitation to further explore and comprehend the universe. Every star and galaxy you see is a thread in the magnificent tapestry that binds everything together. Ultimately, striving to understand this anomaly is part of a larger quest to grasp the vastness of our surroundings and our own part in this intricate celestial ballet. The very idea of an expanding universe can be baffling, often generating more questions than it answers. Chiefly, how can everything be receding from us? To begin to unravel this, you have to look at the Great Attractor's function within this immense cosmic theater. Tucked away in a dense network of galaxies, it isn't merely a point of interest, but a gravitational behemoth, shaping the motion of everything in its vicinity. A common analogy for cosmic expansion is an inflating balloon, with every point on its surface moving away from every other. Yet, the universe is far from being a simple, expanding globe. It is a complex weave of space and time that is actively stretching. Within this dynamic process, the Great Attractor emerges as a principal force, profoundly influencing how galaxies behave within this expanding fabric. So what is the fate of the galaxies orbiting and drifting towards this anomaly? The key is found in their paths through space. Nearby galaxies are locked in a gravitational waltz, simultaneously being pushed apart by universal expansion while being drawn inward by this immense mass. While this might appear paradoxical, it perfectly illustrates the fundamental tension between cosmic expansion and the immense gravitational force exerted by cosmic titans. This naturally leads to the question of what this means for our own local group of galaxies. The Milky Way is an active participant in this grand motion. Even as the universe pushes galaxies apart, our own is simultaneously journeying toward the Great Attractor, though its speed seems modest across such astronomical scales. This dual movement forces you to consider our place in it all. Are we aimlessly adrift, or is our course set toward a specific destination? The Great Attractor's reach extends far beyond our local galactic environment, shaping the very structure of the universe on a much grander scale. The space surrounding this concentration of mass is subject to a stronger gravitational field, which in turn affects how galaxies group together and arrange themselves. You could envision it as a conductor orchestrating a cosmic symphony, directing the movements and destinies of countless galaxies. While the expansion of the universe is a thoroughly established fact, its interplay with the Great Attractor introduces an entirely new layer of complexity. The immense gravity of this object can actually alter the speed of expansion locally, fostering regions where gravitational pull can challenge and even negate the universe's outward push. This precarious equilibrium prompts us to speculate on the ultimate future of galaxies caught in this celestial dance. Given that the universe is expanding, it's logical to question if this outward movement could eventually be reversed by the gravitational pull of structures such as the Great Attractor. Within the field of cosmology, this possibility gives rise to compelling theories regarding the final destiny of the cosmos. It raises the fascinating prospect that we might exist within a cyclical universe, one that endlessly expands and contracts, a notion that compels deeper investigation. Furthermore, the Great Attractor is not an isolated entity. It is an integral component of a far larger cosmic structure, constantly interacting with other massive galaxy clusters and formations. Understanding these interactions is vital for mapping the distribution of matter across the universe, and also forces us to fundamentally reassess our entire conception of the cosmos. As our exploration of the cosmos presses on, the Great Attractor persists as a profound enigma, It stands as a powerful reminder that our understanding is constantly evolving and that vast territories of knowledge remain uncharted. Every advance in astronomy inches us closer to comprehending not just cosmic expansion, but the fundamental nature and vitality of the universe itself. In the end, it's crucial to appreciate that investigating phenomena like the Great Attractor does more than just advance our scientific knowledge. It ignites our imagination. It compels you to question your place in the universe, to contemplate the immense forces at play, and to stand in awe of the magnificent unknown. This endless journey of discovery makes you wonder, have you ever sensed that something truly enormous and mysterious is pulling on everything around you? In the immense void of the universe, there might exist an unseen force known as the Great Attractor, a sort of cosmic lodestone that exerts its will on innumerable galaxies, our own included. How can something so remote and colossal have such a profound effect on our cosmic vicinity? Picture a boundless ocean where every galaxy is an island. In this scenario, the Great Attractor acts as a mighty current, inexorably drawing some of these islands toward one another. When you consider galactic collisions, it's compelling to realize they are not mere random accidents. Instead, they represent movements in an intricate cosmic ballet, choreographed by gravity. So, what does this imply for the Milky Way and its destiny? The tremendous gravitational pull of the Great Attractor could be the very engine driving these galactic meetings, pushing them towards mergers and eventual unification in a process that, while appearing chaotic, adheres to a universal order. The primary question that comes to mind is, what exactly occurs when two galaxies converge? Imagine two sprawling cities on a collision course. As they draw nearer, their infrastructure and inhabitants inevitably begin to mingle. A similar phenomenon unfolds with galaxies, where their stars and vast clouds of gas are pulled into a shared gravitational embrace. Although the individual stars are too far apart to crash into each other directly, their gravitational fields interact, establishing entirely new cosmic dynamics. But what about the galaxies that aren't on a direct trajectory toward the Great Attractor? They too are subject to its influence. As these stellar systems journey through space, the gravity of the Great Attractor serves as a guiding light, steering them in its direction. This suggests that even galaxies appearing tranquil today may be traveling along a path that will culminate in an unforeseen encounter far into the future. A truly captivating element of this phenomenon is the timescale over which these collisions unfold. Galaxies do not simply merge in an instant. The process can span billions of years. Therefore, while you currently perceive the Milky Way and Andromeda as distinct cosmic entities, in the remote future they are destined to join in a celestial hug. This serves as a potent reminder that the universe is a vibrant, dynamic arena where interaction is perpetual and change is the only certainty. When you consider the sheer scale of these collisions, the outcomes are staggering. The merger of two galaxies can give rise to completely new formations, with compressed gases igniting the birth of new stars and reshaping the entire galactic landscape. The eventual union of the Milky Way and Andromeda, for instance, will not only alter the form of both galaxies, but will also reshape their cosmic environment, all with the Great Attractor directing this celestial performance like a grand conductor. A question you might naturally ask is what impact these collisions could have on life here on Earth. Fortunately, while these events are monumental on a galactic scale, the distances separating individual stars are so immense that the probability of our solar system being directly impacted is incredibly slim. Nevertheless, observing these mergers provides us with a valuable portal through which we can view both the past and the future, helping astronomers better understand the Great Attractor's nature and its sway over the cosmos. This investigation leads us to another fascinating inquiry. Are there other phenomena in the universe comparable to the Great Attractor? The answer is a definitive yes. Astronomers have identified other massive clusters and superclusters that similarly function as hubs of gravitational pull. This indicates that the cosmos is replete with these immense forces that are actively sculpting its ongoing evolution. Considering this, it's remarkable to think that the Great Attractor's influence isn't confined to its immediate neighbors, but likely stretches across much vaster cosmic territories. Gravity stands as one of the universe's foundational forces, and while you cannot see it directly, its effects are indisputable. The notion that the Great Attractor is gathering galaxies along its path creates a profound sense of awe, reminding you that despite immense distances and the seeming emptiness of space, everything is interconnected within a cosmic web of mutual influence. Ultimately, when you reflect on this immense scale and the critical role the Great Attractor plays in the ballet of galaxies, you come to see that we are all part of something far grander than we can possibly fathom. Every star, every galaxy, and every collision narrates a part of the story of the forces that have molded the universe since its birth. And while the future of the Great Attractor and its ultimate effect on us remains a mystery, one thing is certain: our curiosity and our drive to understand will relentlessly push us onward. Have you ever paused to consider how an object as colossal as the Great Attractor can actually mold the shape of the entire universe? The answer is gravity. The same invisible force that grounds you to the Earth also operates on a titanic scale, sculpting the very architecture of the cosmos. On this grand stage, the Great Attractor assumes a pivotal role, much like a maestro guiding galaxies through their celestial motions. To visualize this, you can imagine the universe as a vast, taut sheet, where each galaxy is a tiny speck and the Great Attractor is like a heavy weight placed at its center, causing the fabric of space-time itself to curve. The closer you are to this massive object, the more intensely you feel the slope of that curve. Consequently, all galaxies within the Great Attractor's sphere of influence feel the pull of its powerful gravity, moving and circling around it like tiny vessels caught in a cosmic whirlpool. This creates a fundamental tension between the expansion of the universe, which pushes objects apart, and the gravitational attraction pulling them together, a delicate balance that ultimately determines how matter is distributed on the largest scales. You might then wonder what the universe would be like if the Great Attractor never existed. Without such a potent gravitational force at the heart of our local galactic neighborhood, you would likely observe a cosmos that looks entirely different. The expansion of space might be much more uniform, and the paths of galaxies would be far less defined, resulting in a structure that lacks the intricate web-like patterns we see today. Without this cosmic coordination, you might witness a universe in disarray, with galaxies drifting without purpose. A captivating element of this puzzle is how the Great Attractor could mold the very destiny of the cosmos. Should its gravitational pull be sufficiently powerful, it might dictate the future for all galaxies caught within its influence, potentially drawing ever more of them into its grasp to forge even larger superclusters as the universe expands. This process, however, is far from straightforward, as the immense gravity of the Great Attractor produces significant side effects. For instance, galaxies that venture too close can have their shapes and structures warped by intense gravitational forces. Picture a group of friends running toward a set of swings. As they get closer, they might bump into one another, altering their game and changing their collective dynamic in unexpected ways. But what becomes of the galaxies situated much farther away? The Great Attractor's influence certainly diminishes with distance, yet it never completely vanishes. This implies that even the most remote galaxies are likely caught in its gravitational web, even if the effects are far more subtle. Imagine dropping a pebble into a calm pond. The ripples extend outward, touching every part of the surface, even when their direct impact is no longer visible. The manner in which the Great Attractor affects the universe also opens up compelling questions about dark matter, that enigmatic substance we cannot see, yet which appears to be central to gravity's function. Is it possible that dark matter is what lends the Great Attractor its incredible strength? Unlocking this connection might be the very key to comprehending how the universe's largest structures are assembled. As you explore these concepts, it's crucial to recognize that the Great Attractor is not an isolated entity. It exists within a bustling cosmic neighborhood, surrounded by other galaxies, clusters and filaments that all interact gravitationally. This intricate network of influences forges a constantly evolving cosmic landscape, where the Great Attractor is merely one significant component of a much larger puzzle. So, what does any of this signify for us, here in our own small segment of the universe? The presence of the Great Attractor serves as a powerful reminder of our profound connection to the cosmos. Every particle, star, and galaxy is part of a ceaseless interaction, creating a unified whole that extends far beyond our current comprehension. It reminds you that, while we are minuscule in the face of cosmic vastness, each of us holds a unique place and purpose within this magnificent design. Ultimately, you should understand that the Great Attractor is not merely a physical object, but also an emblem of the profound mysteries that astronomy has yet to solve. With every new discovery about its influence, we move a step closer to deciphering the fundamental secrets of our universe. In many respects, the narrative of the Great Attractor is also our own story, a tale of our position in the cosmos and the enduring questions that drive our exploration. What secrets has this cosmic anomaly kept hidden for so long? This perplexing phenomenon has sparked a multitude of fascinating inquiries, keeping both astronomers and curious minds on a perpetual quest for answers. One of the most significant riddles is how such a gargantuan object can affect its galactic surroundings while staying completely concealed from our view. Could there be something lurking just beyond the limits of our observation? The initial question that presents itself is why the Great Attractor appears to be pulling so many galaxies toward it. Its gravitational field is so potent that it can be felt across billions of light years, which leads you to wonder about the source of its immense power. Is it purely a matter of its extraordinary mass, or are there other, less understood factors at play? As our investigation into the Great Attractor continues, another mystery emerges. What is its actual composition? Some scientists propose that it could be a dense gathering of massive galaxies, with the Norma cluster playing a central role in its gravitational pull. But what if there's more to it? Could dark matter, the invisible substance that constitutes most of the universe's mass, be the main character in this cosmic drama? Since dark matter does not interact with light, it poses an incredible challenge to study. Yet its gravitational signature might hold the explanation we're looking for. A further enigma appears when you factor in the expansion of the universe. In a cosmos that is perpetually stretching apart, how does the Great Attractor manage to maintain its hold on distant galaxies? This suggests a fundamental conflict between cosmic expansion and gravity, a dilemma that has fueled captivating debates among astronomers. Is it possible that these two seemingly opposite forces have reached some form of equilibrium? Delving deeper into the secrets of the Great Attractor uncovers even more perplexing questions. Why have we been unable to see it directly? Despite its undeniable influence, any light it might emit is incredibly faint and is further obscured by the galaxies located between it and us. This forces you to question the limits of our current technology. Are our instruments simply not advanced enough? Or is there a facet of physics that remains undiscovered? And then there is a question that fascinates many. If the Great Attractor is truly so massive and influential, what would happen if it ever drew near our own Milky Way galaxy? Could its gravity be enough to tear our galactic home apart? Imagine a colossal tug-of-war between cosmic titans. While the idea of such an encounter is unnerving, it also encourages reflection on how gravity acts as both a creative and a destructive force throughout the universe. Within the broader field of cosmology, one question is impossible to overlook. What do these mysteries reveal about the ultimate fate of our universe? If the Great Attractor continues to exert its influence, could it one day overpower cosmic expansion? This might lead to an entirely new cosmic state, where galaxies are clustered together in a completely different arrangement. Such questions are not only compelling, but are also vital to understanding our own existence. In the end, the Great Attractor is more than just an object for scientific study. It stands as a testament to humanity's drive to comprehend the unknown. It symbolizes our relentless search for answers and our desire to make sense of our place in the vast, mysterious cosmos. Every new hypothesis about the Great Attractor's purpose and composition inches us closer to solving the universe's greatest puzzles. Yet it makes you wonder just how much remains unknown. Astronomers are merely beginning to probe the depths of what this cosmic anomaly can teach us, and we are compelled to ask if other, similar attractors exist throughout the cosmos. The chance that the Great Attractor is not unique, but one of many such phenomena hidden in the void, dramatically expands our view of universal structure and galactic interconnectedness. What other cosmic surprises might be waiting for us? The very presence of the Great Attractor has fueled a wide range of alternative theories that challenge our current models of the universe, especially concerning the forces that truly guide galaxies in its vicinity. Science thrives on a constant search for truth, and each question that emerges opens up entirely new avenues of possibility, which is why we will now delve into some of the ideas surrounding the Great Attractor and its enigmatic pull. One of the most compelling explanations suggests the Great Attractor could be an exceptional concentration of matter, composed not just of the stars and galaxies you can see, but also of invisible dark matter. Picture yourself at a gathering where a captivating group of people commands everyone's focus. This group, though perhaps subtle, exerts a social gravity that draws others near. In a similar way, dark matter generates a gravitational pull that, while difficult to observe directly, unmistakably influences the motion of neighboring galaxies. Furthermore, some scientists speculate that the Great Attractor might be a component of an even vaster cosmic structure, something known as a supercluster. You can visualize this by imagining a powerful magnet placed at the center of a table covered with smaller metallic objects. This central magnet, acting as the Great Attractor, dictates the arrangement of everything around it, suggesting gravity doesn't just work locally, but is woven into the fabric of the universe on immense scales. In an even more fascinating turn, certain hypotheses connect the Great Attractor to quantum phenomena, which begs the question, how can something so infinitesimally small affect structures so enormous? Quantum mechanics reveals that subatomic particles can produce astonishing effects on a macroscopic level. This is much like a puppeteer's strings. Though thin and nearly invisible, they skillfully control the movements of a large marionette, illustrating a profound link between the micro and macro realms that remains a vibrant field of research. Another alternative theory centers on the possibility that the Great Attractor is in fact a supermassive black hole, which are celestial objects renowned for their power to draw in anything that strays too close. If this were true, its effect on nearby galaxies could be far more profound than we currently assume. You can think of it as a gigantic oceanic whirlpool, Everything that gets too close is inevitably drawn into its vortex, while only objects at a safe distance can avoid its grasp. The situation is complicated, however, by the existence of numerous competing gravitational forces across the universe. The dynamic is akin to a cosmic tug-of-war, where different galactic clusters constantly pull on one another for gravitational dominance. This interplay results in complex and sometimes unexpected galactic movements that cannot be explained by the influence of the Great Attractor alone. There are also concepts that propose the Great Attractor's influence is tied to the very expansion of the universe. In this model, it not only pulls galaxies inward, but might also contribute to accelerating the outward expansion of the cosmos. This would be similar to how an increasing gravitational pull could cause galaxies to gain speed as they move away, generating a feedback loop with significant consequences for our understanding of the universe's ultimate fate. Investigating these alternative ideas is not just a thrilling intellectual exercise. It forces us to ask deep questions about what we truly understand about gravity and cosmic architecture. If the Great Attractor is merely the visible portion of a much larger phenomenon, what other revelations await us in the vast expanse of cosmology? Each answer we uncover only leads to more questions, challenging our perception of reality itself. This pursuit of answers is like assembling a cosmic puzzle, where every piece connects in ways you would never anticipate. And in the grand game of astronomy, curiosity is the essential fuel driving scientists forward. These alternative theories are simply one part of that perpetual quest for knowledge. As we continue to probe the depths of space, what other marvels will the cosmos unveil to us? In the end, the Great Attractor is more than just an awe-inspiring celestial object. It serves as a mirror, reflecting both our profound curiosity and our current scientific limitations. Confronting these unresolved enigmas makes you realize that every discovery only generates a host of new questions. So, the next time you gaze up at the night sky, remember that there is far more occurring than what your eyes can perceive. The story of the universe is filled with mysteries, and the Great Attractor remains one of its most compelling chapters. Science is a process of continuous discovery and refinement, where today's theories can evolve into tomorrow's established facts. The Great Attractor, with its persistent enigmas, stands as a crucial area of study for grasping our position in the universe and discerning what the future holds. This cosmic anomaly compels us to reconsider our entire perception of the cosmos and its fundamental workings. To help you visualize its effect, think of the universe as a boundless ocean and the galaxies as vessels navigating its expanse. Within this cosmic sea, the Great Attractor functions like an immense, powerful current, shaping the paths of these galactic ships and determining how they group together. This analogy illustrates how its influence extends far beyond our own Milky Way, playing a fundamental role in the grand architecture of the cosmos. The gravitational reach of the Great Attractor stretches beyond the limits of our observation, raising a host of profound questions. What is its relationship to dark matter, and how does it factor into the ongoing expansion of the universe? Dark matter, the elusive substance that constitutes the majority of cosmic mass, appears to be deeply connected to the Great Attractor's existence, with scientists theorizing its gravity is the scaffold upon which matter organizes itself, though the precise nature of this link remains an unsolved puzzle. The Great Attractor also stimulates considerable debate regarding the expansion of the universe. While the cosmos continuously stretches outward, this anomaly serves as a gravitational focal point, a region where galaxies are drawn to congregate. If you picture the universe as an inflating balloon, you can see how even as the surface expands, some points on it might cluster closer together. In this scenario, the Great Attractor acts like a cosmic magnet, pulling in everything in its vicinity. Another captivating phenomenon tied to the Great Attractor is the occurrence of galactic collisions. As galaxies journey through space, some are inevitably captured by this immense gravitational force, leading not only to spectacular cosmic displays, but also offering invaluable insights into the processes of galactic formation and evolution. It prompts the question, could the Great Attractor be the primary driver behind the galactic mergers that ultimately give rise to new, larger structures throughout the universe? We must also acknowledge that the Great Attractor is surrounded by unresolved mysteries. Despite our technological progress in astronomy, many questions are still unanswered. For instance, what are we to make of galaxies that appear to be moving in completely unexpected directions? These anomalies challenge us to determine if their strange trajectories are a result of the Great Attractor's influence, or if other, as yet unknown cosmic factors are at play. Alternative theories surrounding the Great Attractor also serve to enrich our scientific inquiry. Some researchers propose that instead of a single, dominant point of attraction, there may be multiple forces collectively influencing the motion of nearby galaxies. This line of thought opens up a wealth of new possibilities, suggesting the universe could be vastly more intricate than our current models assume, and that what we call the Great Attractor might only be one component of a much larger, more complex system. The impact of the Great Attractor on modern cosmology is undeniable, compelling us to re-evaluate established theories and challenging our core understanding of how large-scale structures form and are arranged in the universe. Continuous research and new findings steadily broaden our knowledge base, with each piece of the puzzle bringing us incrementally closer to a definitive understanding of this cosmic marvel. The intricate relationship between the Great Attractor and other cosmological phenomena is also a subject of intense investigation. You might imagine the universe as a grand orchestra where each galaxy is a musician playing its part. In this cosmic symphony, forces like gravity and expansion are the musical notes that compose the score, and scientists are trying to decipher the melody they reveal about the history and structure of the cosmos. The future of research into the Great Attractor promises to be incredibly exciting. As our technology advances, we are developing new methods of observation that will grant us a clearer understanding of this distant region of space. With every next-generation telescope and more sophisticated computer simulation, we open doors to potential discoveries that could fundamentally reshape our perception of cosmology, leaving us to wonder what revelations await in the coming decades. Contemplating the Great Attractor inevitably leads us to reflect on our own existence within this vast universe. While we may be an infinitesimal part of this immense cosmos, our innate curiosity and our drive to comprehend the unknown are what make us truly unique. This shared pursuit of answers about the Great Attractor not only deepens our understanding of the universe, but also unites us as a species, inspiring us to gaze at the stars with both wonder and determination. Every new insight gained about the Great Attractor represents another step forward on our journey to comprehend the universe. It serves as a powerful reminder that even in an age of unprecedented scientific knowledge, there is still so much left to explore and discover. In this way, the Great Attractor has become a symbol of our unending quest for knowledge, a beacon that guides our exploration through the profound darkness of the unknown. The future study of the Great Attractor is a thrilling prospect that sparks both immense curiosity and profound wonder. As scientists persist in their efforts to unravel the universe's secrets, the critical question remains: what breakthroughs await us in the investigation of this enigmatic phenomenon? We stand at a pivotal moment in astronomy where each new piece of data holds the potential to completely transform our perception of the cosmos. Have you ever stopped to consider the immense scale and complexity of our universe? Within this seemingly infinite expanse lies an incredible phenomenon that truly captures the imagination and makes you question our position in the cosmos: the Great Attractor. What does its existence reveal about the very fabric of the universe? This cosmic mystery might just hold the key to unlocking some of the most profound secrets of reality. With every technological leap forward, from more powerful telescopes to sophisticated computer simulations, we gain new perspectives on this enigma. These advanced tools function like a magnifying glass, allowing us to examine the fine details of the cosmic map. They enable us to see far beyond the limits of our own eyes, deepening our comprehension of the gravitational forces that steer the galaxies in our cosmic neighborhood. Imagine a colossal invisible magnet positioned in deep space, inexorably drawing everything in its vicinity toward it. As research progresses, scientists are starting to piece together how the gravitational influence of the Great Attractor has shaped the movement and evolution of galaxies over billions of years. This knowledge is not only vital for understanding the present state of the cosmos, but also offers critical clues about the eventual destiny of our own Milky Way galaxy. Imagine a colossal, invisible magnet positioned in deep space, inexorably drawing everything in its vicinity toward it. As research progresses, scientists are starting to piece together how the gravitational influence of the Great Attractor has shaped the movement and evolution of galaxies over billions of years. This knowledge is not only vital for understanding the present state of the cosmos, but also offers critical clues about the eventual destiny of our own Milky Way galaxy. It's a staggering thought that at this very moment, the Great Attractor is gently but persistently pulling our galaxy, along with countless others, towards its center. As galaxies travel and draw nearer to one another, this cosmic migration could result in spectacular collisions and mergers. These galactic interactions are like an intricate game of cosmic dominoes, where the motion of a single galaxy can set off a chain reaction affecting many others, raising the question of what the universe might look like billions of years from now. Dark matter, which is believed to be a primary component of the Great Attractor's gravitational power, continues to be one of the greatest unsolved puzzles in cosmology. As scientists pioneer new techniques to investigate this mysterious substance, they hope to uncover how it is woven into the structure of the Great Attractor and how it affects the expansion of the universe itself. Computer simulations are completely changing how astronomers investigate the cosmos, providing them with the ability to build highly detailed models of how galaxies behave under the Great Attractor's immense pull. Each new simulation holds the potential to yield unexpected discoveries, which could challenge our existing assumptions and open up entirely new fields of scientific inquiry. As we look to the future, we must also account for the evolution of our observational technologies. While instruments like the Hubble Space Telescope have given us breathtaking views of the universe, one can only imagine what will become possible when even more advanced telescopes are deployed. With each new generation of observatories, the prospect of directly observing the Great Attractor and its surroundings becomes more real, potentially revealing new galaxies and phenomena that will help us finally understand its true nature. Scientists are also deeply invested in exploring the link between the Great Attractor and the continuous expansion of the universe. How does the immense gravitational force of this structure relate to the outward push of cosmic expansion? Finding the answer could fundamentally alter our understanding of modern cosmology and the way the universe evolves over cosmic timescales, presenting a puzzle that continues to captivate researchers worldwide. In the meantime, The Great Attractor stands as a powerful symbol of the questions that still await answers in our exploration of the universe. While science consistently marches forward, it seems there are always more questions than answers, with each discovery unveiling new doubts and deeper mysteries. International collaboration is a cornerstone of this future research, as scientists from across the globe working together create synergies that greatly enhance our collective understanding of this phenomenon. This diversity of perspectives and methodologies can spark astonishing breakthroughs that may completely redefine the trajectory of astronomy. Ultimately, it is crucial to think about how these advances in our knowledge of the Great Attractor might shift our perception of our own place in the cosmos. As we peel back the layers of cosmic mystery, we are faced with profound existential questions about our origins and our ultimate fate, prompting you to wonder about our role in this ever-unfolding cosmic story. To put it simply, the future of research into the Great Attractor is filled with exhilarating possibilities, where each new finding could reshape our entire model of the universe. With every answer we find, new questions emerge, and so the unending quest for knowledge continues. The tale of the Great Attractor is just a single chapter in the grand narrative of the cosmos, leaving us to wonder what marvels still await us in the future. In this narrative, dark matter presents itself as a riddle inside a mystery. It's a substance you cannot perceive or handle, yet its presence dictates the very structure of galactic clusters. The Great Attractor might even serve as a reflection of the fundamental forces that shape our lives here on Earth. This immense gravitational anomaly compels you to rethink your entire concept of gravity, revealing it not merely as the force holding you to the ground, but as a cosmic web connecting entire galaxies. Could this profound gravitational link be a larger metaphor for how we are all interconnected in our shared pursuit of understanding and exploration? The Great Attractor also serves as a poignant reminder of how delicate our own existence truly is. Within an expanding universe where galaxies continuously drift further apart, this phenomenon stands out as a stark exception, a powerful force that bucks the universal trend, posing questions about the ultimate destiny of the cosmos. This leads you to wonder about the distant future and whether we are on a cosmic collision course with this anomaly. The very presence of such a mysterious object challenges our fundamental beliefs about space and time itself. In a universe where time is not a straight line but can bend and stretch, the Great Attractor could be our gateway to a far deeper comprehension of reality. By studying its influence, you have to ask if we are standing on the brink of an entirely new era in physics. Every new insight gained about the Great Attractor is another piece of an immense cosmic jigsaw puzzle. As you fit these pieces together, a host of new questions arises, prompting you to consider what other unknown forces might be shaping the universe. It makes you realize how much more we need to learn to fully grasp gravity and its pervasive impact on our daily lives. The Great Attractor also inspires a certain philosophical introspection. If you imagine galaxies as a vast community, then the Great Attractor acts as a central figure, orchestrating their movements. This naturally leads you to question if similar, unseen forces might be directing the course of our own lives, turning the search for answers into a journey that is both scientific and spiritual. Contemplating our position in the cosmos, this cosmic anomaly shows us that while we may be infinitesimally small in the grand scheme, each one of us has a significant part to play in the unfolding story of the universe. First and foremost, the Great Attractor's existence highlights the foundational power of gravity in sculpting the cosmos. It functions like the conductor of a grand galactic ballet, with every star and galaxy performing its assigned role. The Chronicle of the Great Attractor isn't merely a scientific record of discoveries. It's a testament to the evolution of human thought, from the first curious observations to the sophisticated models we now employ to chart its influence. Gravity, the very force that anchors you to Earth, is the fundamental key to decoding the Great Attractor. In its absence, the universe would descend into chaos, with galaxies aimlessly wandering through the void. This raises a compelling question. How precisely does the gravity of this massive structure affect the galaxies in its vicinity? Picture a dance floor, where some individuals are irresistibly pulled toward an unseen center of attraction, while others seem pushed away, creating a dynamic celestial choreography of mergers and collisions. Considering the Milky Way, you cannot overlook its specific place within this intricate network. We inhabit a massive galactic collective, and the Great Attractor is a crucial factor in determining our cosmic trajectory. This reminds you that we are in perpetual motion, that our galaxy is not a solitary island, but an integral part of a much larger, interconnected system. So the next time you gaze up at the night sky, remember that each of those shimmering lights is on a grand voyage, steered by forces we are only just beginning to comprehend. The cosmic microwave background radiation, often described as the lingering echo of the Big Bang, provides invaluable clues about the universe's structure and the Great Attractor's place within it. It serves as an ancient manuscript, revealing secrets of the distant past and allowing you a glimpse into the history of everything. Similarly, the observational methods we have developed to study this phenomenon are a profound testament to our own ingenuity, from powerful telescopes to complex computer simulations that model galactic dynamics. Dark matter, the elusive substance believed to constitute the majority of the universe's mass, also has a pivotal role in this story. Without accounting for it, many of our current theories about the Great Attractor would simply fall apart. It acts like the invisible scaffolding of the cosmic stage, an unseen presence that shapes every event. The endless pursuit of knowledge is a journey without a final destination, and the Great Attractor is but one of many captivating waypoints on this extraordinary path. Each answer we uncover about dark matter paradoxically opens the door to even more questions, pulling us into a perpetual cycle of discovery. When you contemplate the grand architecture of the cosmos, the Great Attractor emerges as a crucial landmark. You might wonder how it fits into the ongoing expansion of the universe, and the answer is that it acts like a lighthouse in a cosmic sea, helping us navigate the profound interconnectedness of everything that exists. This universal expansion isn't a singular occurrence. It's a fundamental part of a sweeping cosmic story that began with the Big Bang and continues to unfold today. It's truly captivating to imagine the future of the Great Attractor and how it will keep influencing our perception of reality. As our astronomical tools and techniques become more sophisticated, this gravitational anomaly is guaranteed to remain a central focus of intense scientific investigation. What profound new realities about the cosmos might we uncover in the years to come? This journey of exploration is an unending one, where every solution we find empowers us to formulate more sophisticated and challenging questions. The Great Attractor ultimately provides a lesson about our own position within this immense cosmic expanse, serving as a reminder that while we are infinitesimally small, your capacity for inquiry holds immeasurable power. So, you have to ask, what is your part in this grand cosmic symphony? Every one of us has the potential to contribute to this universal search for answers. And it is through that very process that you can forge your own meaningful connection to the universe. We should therefore see the Great Attractor not merely as a celestial object, but as a powerful symbol of our collective and unyielding pursuit of knowledge. Every breakthrough edges us nearer to grasping the universe's deepest enigmas. leaving us to anticipate the new marvels waiting just over the horizon. As we continue to push into the unknown, the Great Attractor will persist as a mental touchstone, reinforcing the idea that the voyage of discovery is truly without end. Your curiosity is the very engine of scientific progress, and in a cosmos this vast, there will forever be new frontiers for you to explore.